Hey everybody, how's it going? All right, are we ready to recover from lunch and from that amazing talk we all just watched together? I think that was pretty great, wasn't it? I think I understood about 7% of it, and I was still impressed. So I'm Steve. I'm actually pretty new to this community. You'll hear more about that in a second. But yeah, that was pretty great. Today, though, I'm going to talk about Google stuff. Specifically, how we learn from incidents inside of Google. First incident of the day is the clicker stopped working. I think I have to click on it. The little clicker thing. Maybe I'll just do this. All right, let's just do that. So Google's big. You knew that already. It's also complex. You probably guessed that. But the outcome of that is that we have a lot of incidents that we can learn from, which is good, right? We as a group see that as a good thing. It's not always thought of in that way by all parties, but I think we can recognize that having decades of incidents is actually positive, right? We also have this kind of new thing called GCP, or a cloud, in which we have another layer of complexity, which is what we call customers, right? And so having more of this complexity just gives us more chances to learn. So we're going to talk through that. I'm going to talk through a bit of how we programatize. I'm not sure if that's a real word, but we've made it up. This learning from incidents, how we make it into a program across Google, and how we make it so that as a large organization, we reasonably consistently learn from these incidents in an effective way. And does it work? Does it actually have a good outcome? And then at the end, we'll talk about that so what, and we'll talk a little bit about some of the future stuff. STPA and CAST are things I just learned about in the last couple weeks, which I think are going to be a lot more relevant in the future. OK, so speaking of big, here's a bunch of numbers you can look at and a bunch of logos. I think we know that Google's big, but here's just a sense of scale. And so part of that scale is, like I said, lending towards more, square footage for incidents, if you think of it that way. You can talk about all the different products. Here's just some random ones I happen to pick. And then there's a bunch more at the bottom that I didn't even pick on. So it's just big. That's all we're getting at here. The other half of this is its complexity, is that each of those products, while also big, is actually quite complex underneath. So there's this whole system called Borg. There's this big network that it all runs on. There's thousands of microservices is like a very generously low number. It is very complex. It's also been built up for the past 20-something years, so I'm sure that's helping as well. We also have things like locales, right? We're a global system. We have to work in many parts of the world under many languages. It's just more levels of complexity. And this is a fun one that someone helped me come up with, is that we are also the target of state-sponsored attacks. So just yet another form of complexity in case you were looking for more. So one last thing that Google kind of has going for it, if you want to look at it that way, is that people think it's always up, which is great. It's a good thing to have as a business, but as an operator, this is hard to do, right? This means you have to keep up with this over time. So the term Google's always up is something that you hear get thrown around. We know that's not true. I like to joke that it's always slightly down. You just can't tell. So if we talk about 5 nines, I think most people here are familiar with the nines concepts. That's about 5 minutes of downtime per year. But this is spread across multiple different products and graceful degradation. It gets very complicated very quickly. But the idea here is if we want to be in this always up sort of situation, you have to have advanced capabilities like the generic concept of auto-healing, whatever that means. Whatever goes into that bucket of auto this and auto that, right? You can't have the thing go down, someone notice it on a big screen, step in and type some commands into a terminal and hit enter and then go clink some beers later. It doesn't really work that well that way. There's a link at the bottom here. You can get it later on the slides. This is a talk from Brad Calder, which goes into a bunch of the details behind making the system more resilient. It's at a pretty high level, but it's a really good talk. I highly recommend it. OK, so if we have this scale of complexity and just scale in terms of size, we know that means that we're going to have more incidents But doesn't mean that we have to have more impact. This is something that we want to try to minimize, is the impact part of that. If we know we can't control the number of incidents, or we can't eliminate all incidents, we do want to try to make the impact of each of those incidents smaller. And we do that by trying to make our systems more understandable so that we can make the incidents themselves less painful. We actually have a good culture for this already, or we have developed it over the past 20 years or so. This comes from the SRE concept, the culture. Ben Traynor has a quote here saying 100% is the wrong reliability target for basically everything. I think this is a good place to start. I've been at other companies and I've worked with other companies where they don't subscribe to this, where they want 100%. And it's really hard to get anywhere with that mentality in place. You kind of have to get at the culture first. So I'm an SRE. These are some pictures from my personal photo gallery of like diagrams of systems that I have worked on in the past. Don't try to read what they are. Like, I don't even remember what they are. But like, this is what we do as SREs, is we sit around and draw stuff on whiteboards and go like, how could this possibly break? And I've got a bunch of good ideas. So I like to think that Google's take on this whole reliability thing comes out to this SRE thing. We've seen some books. But I recognize that this is just something that we built at Google, right? It didn't, it's not a superset of all possible ways of solving every problem, clearly. It's just a kind of the thing that worked for us. The resilience engineering group, the safety engineering kind of community that is here, like, I'm new to this community. So like, if I get things wrong or if I overlap some words, like, please tell me. I'm willing to learn. I come from the SRE world. I was there for a long time, so I may overstate some things in that direction, but please let me know. I have to say I'm a little bit intimidated being at this conference because I'm used to being like the fancy Google SRE guy at SRE conferences. That's not what this is at all. So please help me out if you see me after, and let me know where I messed up, and I'll fix it. I do think there's an overlap, though. Like, it's not like there's safety and resilience over here and there's SRE over there. Like, there's something. Like, I don't know what the Venn diagram is, but it's not a null set, right? So what is SRE? I know we always define SRE when we give a talk about SRE, and I apologize. But this is my latest one. This is purely in case you're not familiar with SRE at this point, which seems kind of doubtful, but who knows. But the terms that you should care about are the ones that are highlighted, right? That's how these slides work. We are familiar with the concept of like the Swiss cheese model of defense in depth. We don't subscribe to merely applying a bunch of solutions and saying, oh, we're done. So SRE is actually, I think we have discovered some of the things that are in resilience engineering alongside or at the same time, but we just have a bunch of different words for it as well. Like, you've probably heard about, postmortems. That's kind of a dark word. Like, and then we have other terms that overlap quite a lot. One of the most important things here is the one that's in red, of course, which is that SRE subscribes to something called practice, right? Like, if you do know how to solve a problem and you have it like in a run book, that's not enough. You actually need to do it, right? You need to try doing it. You need to have what we call round tables or tabletop exercises, right? And actually do the work. Sometimes it can even just be in theory, like we kind of akin to Dungeons and Dragons, right? We have the dungeon master, and you walk through a problem. But we don't just rely on something being written somewhere in a book. You have to actually practice it, because we know the system changes underfoot all the time. OK, so let's focus on GCP a bit, just because that's where I work. And I want to talk about how it works with customers. So lots of words. Apologize. You can focus on the colored and bolded ones if you want. One thing that is special about cloud is that if you're using cloud computing, you are necessarily making changes to the product itself. Like, you are writing code in it. It's very rare that you buy a VM or rent a VM and just leave it there, right? If you do that, like, I mean, thank you for the $2 or whatever, but like, probably not the best use of your time. So that means that there's necessarily at least two parties at play here in whatever it is that you're doing with the cloud. So it's going to be your company, and it's going to be Google, right? And there might even be more parties than that. So we're already getting a little complex, right? or complicated, I'm not really sure. So one of the things that can occur here when we have these two parties, these two organizations that might be quite large, each of them, is a mismatch of expectations. And that can be between the developers who are building the code for whatever the product is that they're building on the cloud, and the documentation, or the API, or their understanding of how cloud works, right? Often you can giggle with me that documentation isn't perfect. In fact, we have a lot of under-documented or undocumented parts of the system because the system is ever-changing and it's just so big and complex. And also, we have this thing called emergent behavior, which all large and complex systems have. It's quite hard to document emergent behavior, I would imagine. Also, things like failure modes, failure domains, tend to be poorly understood and documented also. Like they're this extra special category of stuff that's even kind of harder to understand. I don't know if the term sunny day engineering means a lot to most people. This is sometimes called like happy path engineering as well. I see this occasionally with customers where they will just write the non-defensive code and just kind of, it should just work like this. And we kind of have to say like, yeah, until a bad thing happens, right? We have to account for failures. And sometimes this is like a strangely foreign concept. And so just getting that across is really important as well. So not all firms are at the same level when it comes to this type of thinking. Finally, when it comes to other terms, or other firms, sorry, there's also culture. So if you're familiar with the Dora project, we have a fair amount of work towards the helping cultures helping companies improve their culture with regards to like DevOps and like releasing software. One in particular is what I'm calling risk dumping. I don't know, again, if there's a better term for this or not. And it comes from the idea of if, as per this note at the bottom, I hope you can see it if you're in the back there. This comes from the Westrum model. You've probably heard of that as well. A pathological organization might have responsibilities shirked. That's not great, right? A generative culture would have risks that are shared. That's probably a lot more effective when it comes to dealing with risks that come up. Like, are you going to hide them under the table? Or are you going to dump them on someone else, or possibly your vendor? Or are you going to like accept the risk and do something about it? And this is up to the culture of the company that is interacting with this cloud product. This makes this whole system really hard to keep running. Okay, like I said, I'm new to this group. I did find the Stella report. I was pointed at it by some folks, and this one popped out at me. I think this might also be the same one that was presented this morning. But the idea of maintaining adequate mental models is, I think, part of the trouble that we have when cloud customers are adopting cloud, especially kind of in the beginning, and especially when it comes to things like failure domains and dealing with incidents. Especially when they have a background of running their own infrastructure and running their own entire stack. Like they've moved from one world to another world, and their mental model has shifted. Often we need to, as a cloud provider, we need to not just ignore this problem, not just say like, I wish our customers were better, but we need to recognize that there's this gap, right? So we call this customer empathy. And not just like, hey, it's documented, why don't you just figure it out? We have to actively go after it. So this means also like improving the UX of cloud products to improve where people are stumbling over things, right? And finally, of course, there's just pure education, right? Getting out there, doing advocacy, specifically around reliability, which happens to be exactly my job, which is why I like to talk about it. Okay, pop quiz. This is meant to be a quiz that you just have in your head. This group of people will probably answer all in one direction or in a similar way. When I have this conversation with large groups of people, customers, it almost always ends up 50-50 split when I have them raise their hands. I'm not going to have you raise your hands, don't worry. But the point of this is not to show what the answer is. The point is this isn't an easy question because it's almost always a 50-50 split. I think that's really fascinating. I actually asked this question to a room of 2 people the other day, and I got 50-50. I got 1 and 1. It was amazing. So think in your head, what's the answer? Okay, that's the answer, right? You can definitely do this. Now, remember, people answer no to this question quite a lot. When I go and talk to them about resilience and reliability and cloud and SRE and all this stuff, Very often people answer no to this question, and they're the ones who are making decisions for their companies about cloud, right? This means like we need to help people understand this a little bit better. If you're not sure about this, think about RAID, think about disk drives failing. If you put a bunch of disk drives together into this RAID thing and add a little redundancy and a little bit of extra complexity, it becomes this thing called like a SAN, and it's far more resilient, right? So you get more out of something that is less. Here's another analogy for you. So we call these the pyramids or the triangles. On our left side is kind of the traditional model, which is we have this really solid base and we put our apps on top of it. And as long as the base is reliable, we inherit that reliability from that base. And it's great, right? But it means that the lower levels have to be more reliable than the above. So if we remember the quiz we just had, that doesn't work, right? It doesn't, that's when you answer no to the previous question. So on the right side is if you answered yes to the previous question. You know that we can build scalable systems out of parts that are less reliable than, the bottom is less reliable than the top. That means that we have to add complexity to the system itself in order to achieve this. So the top is wider to kind of indicate that there's more resilience built into it. It's complexity, we get it, but you get more out of it. So like, why on earth would you do this? First thing is just to understand these are two different models. If you're thinking about the left side, but you're living on the right side, you're going to have a problem, right? Or the other way around. Sort of like choose one. Try not to do both at the same time. Just pick one, right? OK, so the left model worked for quite a long time. In fact, it continues to work in many places just fine. This is a common mental model that a lot of companies have. However, cloud is on the right side. I'm sorry, it's just true. Right? And the reason why is scale. Like in order to scale up to like mega cloudiness around the world and move fast and all these things, you're living on the right side. It's just true. The joke at the bottom is you can't buy more 9s for your VM in the cloud. I've had people ask me that. Can I just pay more and have more 9s for this VM? Like, can you just leave it up all the time? No. The answer is no. I'm sorry. OK. So let's talk about incidents when it comes to customers. So clouds are great until they're not, right? Like they're like anything else. Sometimes there are incidents and customers are affected by them. And I mean like businesses like they're not up, right? And that's really bad. So when this happens, they naturally ask these questions to us because we're their provider. They say like, why did this happen? Like really bad is if they say something like, why were we the only ones affected? Right? If you're the only one affected by like a provider problem, it hurts. Like you take it personally, and I get it. Like it's not great. My favorite is, didn't you test for this? Yeah, okay. It's hard to answer that question. This is really understandable that people ask these questions because the outcomes of this can be really, really bad. Right? If you build your system and base your entire business on it, think of if you're the only person who owns a business and all your income comes from this thing and it goes down. That's bad, right? What about if you have a bunch of employees? Like they're now affected as well. Like there can be really bad outcomes. OK, aside about GCP specifically, all that other stuff we talked about, all those 9s and Android and search and all these things, those actually run on the same system. So GCP runs on Borg just like everything else. Things like search and ads and Android, they don't use the same like zones and regions that cloud talks about in terms of abstractions. They use the same concept. It's not exactly the same, but conceptually it's the same. So the point of this is that it is possible to build highly reliable services, Google's always up, on this particular set of infrastructure. So we don't think that it's actually the infrastructure that's at fault when we have customer outages. We think something else is at play. Right? Surely there are incidents that are like based in infrastructure problems. Like I'm not saying there aren't infrastructure problems, but things like search and ads can recover from them. So why can't some customers? And this is the problem that we're getting at. And it's about complexity and assumptions, like we said at the beginning, right? So customers just want to say like, hey, just tell me how to run like Google. Like I get this all the time. Please come in. Tell us how you do it, so that way we can just do it like that. The answer, there isn't one way, right? The best we've done is to publish the SRE books, and that's slowly taking some hold. They're pretty conceptual. They want a simple answer. I get it. I love simple answers to complex problems as well. But if there was a simple answer, we would already have put it straight into the product. And there just isn't a simple answer. Complexity begets no simple answers, I guess. But the secret really is to learn from incidents. We do it internally. Customers need to do it as well. And I'm afraid you have to do it forever. Like, you just have to keep doing it till the end of time. Like heat death of the universe, that type of thing. But it should be fine. You'll enjoy it. OK, so here's an example. This is a customer that built what I call 2 towers, right? Just like Lord of the Rings fans out there. Totally independent towers. I forget the name of them. One's in region 1, one's in region 2. Cool. No shared fate. Except there was. Oops. So this is a problem, right? So this red line denotes like we're out of customers' code and into Google's infrastructure, right? There was this thing called the auth token service that they were making calls to. Not only were they making calls to it, they were doing it in like an inline like data plane way. Like in order to serve a request, they had to call that service like to serve that request, right? So this is an important thing. Auth token generation shouldn't be done that way, right? An auth token generation is, in this particular case, is a thing you do like once a day to regenerate a thing. It's a management plane thing, or it's a control plane thing. It shouldn't go directly in line. But regardless, right? This is just how it was, OK? So they had a client library in their code. Their client library came from like GitHub or something, and it was like the official Google one on how to use this service. And they just like, npm get it or whatever you do, like just pull it down. OK, this is how we call it. Follow the directions. Go. All right, no problem. Meanwhile, n weeks, months, whatever later, Google releases a new version of the service, which is now split across 2 regions, and a new client library. Like they just updated the client library. But what got missed? No one did like a git pull. No one saw that like there's a new version of this library or the service or whatever, and like how would they? How would they know that? Like, is there an RSS feed for this library? I don't know. Maybe there is. I'm not even really sure. But like at the end of the day, like this is a bummer that this happened, because of course what happened, the red thing fell over, both the towers fell, the customers were impacted, the company was very unhappy because the thing that we helped them design, the 2 towers that we said these will never fall over together, they fell over together, right? That was a real bummer. The best part about this is we didn't know about any of this for weeks and weeks and weeks after the incident. It took a long time to figure that out. So in the meantime, it was one big customer. They were uniquely impacted. They were the only ones affected by this outage. Others were affected. It wasn't a big deal. Because remember, they were using this system in a not quite the right way, and they were depending on an old thing, and other teams had moved on, and they hadn't, whatever. But like it felt personal. Why were we affected and not anybody else? So of course, they demand an investigation, right? They're a big customer. They can call people at Google and get them and and they say things like this, we want to make sure this never happens again. Yes, I would love for that to be true also. Why didn't you test for this, right? And we want monthly updates. And we were definitely on the hook for this, right? Because again, remember, we didn't even know what was going on for weeks and weeks and weeks. We were having meetings and meetings and meetings. We were trying to figure it out. And of course, we had this huge response internally to this. This was a hassle. This was not great. OK, so keep that in mind. This happens over and over again, but in many different ways, with many different customers constantly. This is platforms for you. OK, so let's talk about measuring incidents. So we have a system at Google for when an incident happens, how we manage it. It used to be called outage management at Google because that's OMG, and that's hilarious. We can say, like, what about OMG number 5692? However, someone thought that it's not as cool to be as hilarious, so now it's called the Incident Response Management Tool, IRM. I still call it OMG. That's fine. There's a group at Google that's responsible for running this and a bunch of other stuff. They do tooling. They manage communications across the company. procedures and metrics and dashboards and all sorts of things. One of the things they do is incident impact measurement. So how do we know if this is a big thing or a small thing or a medium thing? So you can see, you probably can't read the words, that's okay. It's like a bit of pseudo SQL code saying like there's minor things and medium things and major things and huge things. And they all have different scores associated with them, and then there's like a graph adding them all up. Like, we love metrics. We love dashboards and seeing big numbers. This is basically like Sev 1s and Sev 2s and all that. Same idea, right? So what do we do with this? Like, what's the point of this? What's the context of all this? Like, first of all, like, does this actually work, right? Like, does it make sense to everyone? Because small things in ads are not small to things in Chrome. Like, if you measure just the size of them, because ads is a giant beast and Chrome is not as giant, right? And they might all stem from something in Borg, which to Borg is absolutely tiny, right? Because Borg is this huge, huge, huge beast, right? So like, do these measurements actually make sense to these different teams when they're impacted by them? I don't know. And also, like, does this sizing actually, like, does it come from facts that are present at all points in the universe, or does it change over time? Like, does something start out small and ends up being huge, but actually it was medium? If so, like, what are we doing here? Like, why do we have these words? Are they really helping us? We see it lots of times with customers, at least, that this type of concept, even if it's just Sev 1, 2, 3, they'll actually go back and adjust the severity based on the perceived impact of it to kind of like retroactively adjust. That felt more like a Sev 1. Yeah, it was a Sev 1. Let's call it a Sev 1, right? We'll change it for no real reason. Like, it totally happens. We try not to do that within Google by applying data and algorithms and stuff, but it can happen too. So what? Like, if you have a different sized outage or incident, what is the effort that actually takes place? What are the actions that are taking? Like, do you do different actions for a small that you would do for a huge? Maybe. But like, is it actually telling you what to do by knowing this label? Does it help you pull in other teams? Does it give you more like capital to bring in help? Maybe. That might work. So you might be incentivized to overstate it, or maybe actually you're incentivized to understate it because you don't want the attention. At the end of the day, like, what is this labeling actually doing? This is something for you to just kind of think about in your heads of, there's good things and bad things from labeling, whether it's done accurately or not. Okay. From incidents, and sizes of incidents, we can now move on to capital R risks. So we do have large systems. We have a large surface area. We have a lot of lightning strikes. So we have a lot of things that might be considered risk. In fact, we have giant, giant lists of them. And so what happened is we went around and tried to enumerate them like you would at any, like program management-y, institution. And we went through a couple different methods. So one was bottoms up. Ask all the service owners, tell me all the risks in your system. You know everything about your system. Just write them down. It should be fine. Like, what's so hard about that? We also went top down, where we said there are these categories of risks. We know that there are some risks that are shaped like this, and some that are like this, and some that are like this. So if you have anything that are shaped this way, tell us about it, because we don't want you to just ignore those. And we also went kind of customer-centric with respect to cloud. So we defined like the top CUJs, which is critical user journeys. So example of this is create a cluster in like GKE, or keep my VM running. Like, we would say, what does it take for someone to create a cluster, right? That's very important, right? Keeping a VM running is also very important. Some other user journey might not be quite as important, so maybe we can at least provide some sort of ordering here. Maybe, right? This is kind of standard stuff. And then, so what did we do? We took all of these numbers and we came up with some scoring, because we want to know what it is that we can work on and what it is that we can defer. Right? So the really early one, and I'm responsible for making up this very dumb piece of math, was just likelihood times impact. And like, what is this? Like, likelihood was 0 to 1, a decimal number, and impact was, I don't know, another 0 to 1 or something. And like, we ended up with these crazy numbers. And like, we could order them for sure, but like, they didn't really mean a lot to teams or to customers or anything. So we kind of like moved on after that later. We found a bunch of existing systems that were out there about classifying impact size. NIST has one. There's stuff from like the fire departments, like general purpose, like ways to think about risks. So we're using things like that now. But like this was actually not a terrible place to start. Like it was a non-zero place to start. I do apologize constantly for the existence of this, though. OK, so what are we doing with these numbers and these risks and all these things? We're defining 2 more words, so a weakness and a mitigation. A weakness is basically the extension of a risk against a certain asset. An asset is basically like a piece of a product. So like for instances in GKE, like VMs, what are the risks that are associated with those VMs? And so you're enumerating a bunch of risks and applying them to parts of the stack, parts of the product. And then you're coming up with mitigations. OK, well, to get rid of this risk, we'd have to X, Y, Z. We'd have to build it in this way. We'd have to fix this thing. It would reduce it by 50%, maybe, some number. And we could do it in 17 years or whatever, right? 6 months, right? So these are the fields that we filled out. And then we do what every good program manager does, is we made a big graph with burn downs and charts. And as we discovered new ones, we added to it. And it was great. We all thought it was wonderful. We were able to send these out in newsletters, and we all said hooray when the number went down. It was wonderful. We set OKRs around them. We had teams commit to doing things. One of the things that we were able to highlight out of this is that there were actually some risks that we recognized across the board were pretty common, and that some teams were just ignoring, which kind of made sense because it didn't seem important to them. They're like, well, we have plenty of other big fires to take care of. Why should we take care of this little one if it's not that big to us? So this comes back to like systemic risks versus independent risks. So if there's a category of risk for customers, especially if it's like deep down in the bowels of a recursive dependency chain, it's really important to suss them all out. Right? You want to eliminate an entire class of failure if you can define it and can get rid of it. And it's quite hard to actually get people to do that on their own, right? To align themselves in a way where we actually get rid of one entire type of risk together. If you just wait for it to just happen naturally, you're going to be waiting a long time. So at the bottom right corner is a strange graph that you might not be able to read. I apologize. It has a kind of burn down or burn up chart in green saying like, hey, we're getting this risk removed over time. And the big dots are outages, specifically related to this type of risk. And we found very clearly, as we reduced this risk, the outages kept happening, but their impact became approximately 0. So this feels pretty causal for this type of work. Right? This specific risk reduction, we believe, worked, which is great. So like the bottom right dot, which is gray, was the same trigger as the top left dot, which was a huge outage. Same exact thing happened in production, but no one cared. Like the system was fine, which is great, right? We want to do this more and more and more. So this system was, I'm calling it foo service here. We had to turn it down because we realized through meta-analysis that this thing was unsafe. We had to get rid of it. We had to get everyone to stop using it, right? So we had to have this burn down process. We had to tell everyone about it. We had to get them on board. We had to get their OKRs set and their policies aligned, right? This at the bottom here we see it was over 100,000 different assets had to be migrated off of this thing. It's a big number, right? So this is what I call programmatization, right? This is taking the concept of what are we learning from these incidents? How are we organizing which things to work on first? How are we getting people to agree to work on them in such a way that we're not just shooting in the dark, right? We want to make sure that we can align people's goals. We can provide the right incentives to make sure that we can get risks reduced in a way where it's meaningful to customers. And of course, we have to do it again and again and again forever and ever and ever. And we're cool with that. Providing some motivation is very helpful. Showing an example like the 2 towers model that I showed at the beginning. We showed this to approximately every engineer in Google Cloud. We said, this is what we don't want to happen again. Look at how bad this was for this customer. They lost a bunch of money. It was terrible, right? That is a good motivation. Like people don't want that to happen. It's not like they're like mean or lazy or don't really care. Like they don't realize that some of the changes that they're working on actually have these like effects many layers above them. If you inform them of that, they'll be happy to work on it. Of course, leadership matters as well, right? We need to fund these things. We need to work on this, not that other thing, right? We can't just leave this on the queue and hope it just someone gets around to it. So the work is going to happen, but getting the leadership to really back you up is even better. And of course, we continue to do these types of things over and over again, and they're continuing to kind of be ongoing. We have a concept of this thing called the production principles, which were introduced like 5 years ago. Similar kind of model where there were a bunch of, suggestions or rules or ways of working. People are still applying those today, many years later. Okay, so what? Does this actually help? Sort of. So we're able to show that incidents have dropping impact over time. I showed you the graph before with the bubbles. Like, that's one example. That's good, right? The other thing that this has, though, the other effect that this has, is that we're able to focus our efforts, right? There's like Pareto analysis, right? You don't have to burn everything down all the time. You can start with the big ones and work your way down. You don't necessarily have to get to the end of the list. So we just heard from Dr. Woods, I can't remember what he said exactly, but there's something along the lines of this, is like there's a limited set of resources, even at Google, right? So you can't just expect to burn down every possible risk. So you have to have some method of scoring and weighting and, which one should we attack first? The phrase that I got from a guy who works on this was, what he gets out of it is he can answer the question, are we done yet? And for some value of done, he can actually answer that question. Once we've done these 2 or 3, then yeah, we're done for now. We can move on. This is not unique to Google. We are open to new methods, of course. But I think we can safely say, like, there is some positive outcome to this, or else we wouldn't keep doing it. It's not perfect, but it's good. So what are some future things that we're working on? So STPA and CAST, these come out of MIT. Some of you know this far better than I do. I do know of one application of CAST on a postmortem. So this was an incident in actually my old team, so I was able to understand all the technical parts of it as well. And they found, after doing all the postmortem kind of like the Google way, they came around and did the CAST method on it, and they found 10 more things to work on, which was, awesome. One of them was my favorite, was they found that one of the graphs on a console somewhere was backwards, right? The y-axis. So like the thing that the now time, instead of being on the far right, was on the far left. And this like had a real impact on how the incident was managed by the on-call person, because they were looking at the right side of all the graphs going, weird, weird, weird. Oh, no, that one's fine. Keep going, keep going. They didn't see the big dip or the spike or whatever it was, because it was on the left side of the screen, right? That's a real bummer. And that did not come up in the general or the S3 postmortem. Similarly, the assessment was actually 1% of what it really was, and that was only discovered after doing the CAST thing. We still think that SLOs are good. They help us understand the component level availability, reliability of our systems, but we are recognizing that there's like, the space between the components, right? And we're trying to find better ways to discover this. If you find some talks by, there's a guy named Narayan Desai. He's got a bunch of SRE talks that are about this. They're also really great. Okay, I'm almost done. Don't worry. So what are some outcomes of this? We don't expect the count reduction to go down. We know there will always be more incidents, but we do want the harm to be reduced over time. And we want to do this by understanding what these risks are that were involved in each of these incidents, right? Whether they're new or repeated, and then being able to determine which ones we should mitigate next. So is impact dropping? Yes. Is it necessarily causal from this work? Maybe. Sometimes it is. Like that one graph we showed, yeah, that one pretty darn sure. But like as a whole, I don't know, maybe just the weather's getting better. I don't know what it is. But there are some things that are working. So we're finding that developers inside of Google are using terms like risk and weakness and remediations in their planning documents and in their OKR work. Like they're using the language, which is great. They're talking about customer impact. They're using examples that we've given them in terms of how their risks have actually affected end users in ways to better understand what they should work on next, which is awesome. And as I noted in the graph, there are some legitimately causal reductions that we can point at, which is great. As I mentioned, our developers do want to do good by their customers. They just need to know what to work on now, right? They want to solve real problems. So if we can show end-to-end problems that customers can be like alleviated of, that is one of the best motivators that we can provide. These customers are being affected in this way, and you can fix it by doing this thing over here. Yes, let's do it, right? It's far less abstract. We call this a non-abstract problem, right? So in conclusion, managing risks and LFI in general is hard. Doing it inside a platform, I propose, is very hard, at least to me. It seems really tricky because you have this other entity that you're working with. You don't want to focus on local maxima, right? You want to have a way to make sure that people can understand what the systematic problems are, the platform-wide problems are, so that they can help solve those. It's not just what's in my lens. Incremental learning and improvement is the name of the game here, right? This is what that system or that programmatization thing is that I was talking about, is making a program so people can systematically reduce these risks over time. Getting education across a large organization turns out is difficult. You have to have many forms of education, whether it's videos or educations or seminars or blog posts, or we have this thing called testing on the toilet, which is actually really good. It's a piece of paper inside the door of the toilet stall, and it gets changed every week. It's great. You should totally do it. Steal that idea. Look it up on Google. At the end of the day, like, this work is going to happen anyway, but if you can get leadership and planning behind it, it will be even better. Like, it will, it's one less roadblock that you'll have to have, and you can get funded. If you can do that, even better. That's it. That's how we do it. I hope that helps. Thanks very much.